Okay, so these are a little harder, but I feel like we're detectives. You know, this is a worthwhile thing here. So this is a fairly easy one. You might even just know, but let's just do it here. So the charge, this is -1, and then here this is -1 and 0. And so if we're trying to figure out what this guy is, this guy's going to have no charge because charge is already balanced. We don't need something to balance the charge. There are no electrons here, so this is going to have 0 electron number. There are muons, so let's see, we got 0 is equal to +1, -1. Okay, so muon number is already balanced. It's going to have a 0 muon number, right? Let's look at this. Tau number, we got +1 equals. These guys have mu numbers, but no tau number. So this has to be a +1, right? So what is it? It has no charge. It's not an electron, and it's not a muon, and it is in the tau family. So which one of these guys? It has to have a, it's got to be one of these guys, right? This guy has charge, can't be that one, has to be the neutrino, right? Okay, so it's the tau neutrino. That's our answer. This is a Feynman diagram of that, of course. You know, it's a Feynman diagram of everything, right? And so this tau particle decays basically into its neutrino. The W minus is what mediates this decay. And notice that the antiparticle is going back in time and space. All right. What is this? This is time this way. Time, space this way. It's turned on its side, I think. I don't know.